today. What is AI? Can we even get our hands around it? And a humble effort at simplifying what AI is. This is work that I started thinking about back in October of last year. It's still work in progress. Um, and then what's next? What can we do with this, right? And I'm going to leave you with hopefully some practical tools and things you can do to implement in your profession and your daily life. So, all right, there is no agreed upon definition of what AI is, right? So the experts, the media, the politicians, everybody has a different explanation of what AI is. If you ask young people, like my daughter, she would think Chat GPT is AI. So these generative AI tools, you're looking at the top 50 generative AI web products as measured by unique monthly visits. No surprise there if you look at the top 5, right? Maybe some of these names even are not familiar to everyone. How we consume these tools is also different if you look at it on a mobile device, right? Clearly, number 1 remains the same. However, the number 2 through 5 are different. So, in other words, we're using these AI tools as a consumer, and we want to make sure that we're using it to benefit our lives, our profession, our family, and the community. We have this thing called large language models, which appears to have come on the scene just 2 years ago. And I'll explain how that ties into what AI is. And there are many players. There are more than 20 vendors in this space. So these are either startups or big players, mega players that control a large language model because it takes a lot of computation, a lot of data to create one of these. You can see the list here: OpenAI, Amazon, Meta, Microsoft. It's who's in the tech space, and some startups that are trying to make a difference, and even some nonprofits that are trying to break into this space. Is that what AI is? Is it generative tools? Let's think about that for a moment. We've been generating text and pictures and templates and PDF files for ages, for 20, 30 years. Certainly AI is not about just generating, right? If that's the case, your keyboard on your smartphone has been doing that for you. You type 2OD and it says today, you type GOM and it says tomorrow, right? But now we scaled it to generate a lot more, tens of words, hundreds of words. Let's step back a little bit. AI is really a subfield of computer science. So if you look here, this is computer science with its all glory. I'm a computer scientist by education. AI is one of the topics that we had to study and we take comprehensive exams on. Within AI, there are many other subfields, including machine learning, deep learning, natural language processing, question and answers, and the list goes on. Also, in order for computer science to work, it needs data. So data science actually intersects with computer science and machine learning and AI. So you can see that intersect there. So really AI is a subfield of computer science. There are AI tools, AI methods, AI techniques that we can use for meaning, for money, for peace, or for other means. So AI is a system, software system, or a combination of software and hardware that exhibits intelligent behavior. It doesn't really have intelligence on its own. It pretends to do that. And in order for it to do that, it needs to be augmented with these advanced methods and techniques that come from computer science, that comes from data science, machine learning, and so on. This is my definition, our definition here, best effort at explaining this. And it's not limited to these advanced methods and techniques, but we wanted to limit it to 5 for simplicity. The first one, it learns from previous experiences. So we can teach it by showing it different pictures, different data samples, and it draws patterns from it. It can act on its own. We don't have to tell it and program it for every scenario and every situation. It's not possible. also it's very adaptable. The real world has a lot of uncertainty, and it's changing very rapidly from one moment to the other. Um, so it knows how to deal with uncertainty on its own without being programmed specifically. And lastly, it can perform reliably under most conditions. So if we take this definition and apply it to a person or a physical object, you can see why we call this intelligence, right? It's able to adapt, it's able to learn, it's able to deal with changing environments, and it does it consistently and reliably. Otherwise, not AI. It's really something else. Yeah, so taking that definition, AI for the longest time, and even until today, is all about machine learning. That is giving data to an algorithm and then asking the algorithm questions to predict or to produce something. And that space is a whole subfield of computer science. So, and it deals with either having data that has the answers in it. In other words, let's say pictures of dogs, and we can label it with the actual breed of the dog, or pictures that don't have any labels on them, and then asking an algorithm to cluster them and to try and determine what they are potentially. In other words, we can give an algorithm any picture and call it a dog. It can be a cat, and we can labelize the dog either purposely or mistakenly. And the algorithm will learn that this cat is a dog, and it will say that forever. So machine learning is all about the data itself and how valuable that data is and how clean it is and how trustworthy it is. Um, so the algorithms, there are more than 60 plus different algorithms, and these are like very hard computer sciencey type of things that only the top tier computer scientists would try to tackle or bring new ones. So typically people use these algorithms to do machine learning. Which one you use, that's a subject of a whole uh, new course or webinar. But this is just a sampling of it. It can be as simple as linear regression, where you try to draw a line and separate the data into two clusters, or it can be something very involved, like decision trees or neural networks or random forests. But let's hold on here. Have we said in the definition of machine learning, it can do automation and it can work on its own. Have we not been doing automation? So I was looking around thinking about how can we project this idea. And on the Mac operating system, there's this tool called Automator. And as you can see here, this tool has been around since 2004. It wasn't created yesterday. And it allows you to create these different automations. Let's say you have a whole bunch of pictures and you want to sort them and then create a PDF, or you want to create sort of a contact sheet out of those pictures. You can create an automated workflow to do that for you, and you press a button and it does the work. No real coding is required. And so there are all these steps that you can kind of chain together in different ways to allow you to do that. So, right, maybe you have done that in the past on your Mac or Windows machine, but going back to machine learning, really what's different about machine learning is the data. We have to have data, and data preparation is 80% of the work that goes there. From there, we have to select one of those algorithms or models and train it with that data. And then after that, we deploy it, test it, and tweak it to ensure that it's producing the correct results. So it really is 3 steps. Number 1 looks very simple, but it's actually the hardest one. So what's happening now with large language models is that the data doesn't need to be prepared. We just amass data from the internet, from any source we can. We build these big machines, and then we crunch that data with natural language processing. The preparation is being done by another algorithm. And so therefore, that really heavy load of data preparation has been lifted, but that load was being done by humans that made human decisions about what these things are. I'll show an example in a moment, and that will hopefully make it clear to you. So here is an example. Let's say we want to predict house prices in a particular zip code. The data that we need is historical data about prior sales. and we need to understand the house features, how many bedrooms, how many bathrooms, square footage, lot size, et cetera, and the price. And then we can apply linear regression and ask a question about a new house that came on the market and ask the algorithm, what do you think the price should be based on the historical data, right? So here, humans are preparing the data set. We have to have spreadsheet or a comma separated value file with sufficient data in it to be able to make a reasonable prediction. With large language models, we don't need to do that. We simply ask the question, here's a house in this zip code. What do you think the house price should be? And it's going to use natural language processing to parse prices for data from multiple sources. Some of the sources might be authoritative and trustworthy. Some might be not so. Some may have very little value or even relevant to that zip code. So that's a big differentiator between machine learning, traditional machine learning and LLMs. So the data set is those features and attributes. You have to have enough. In this example, there are 13 different attributes that allow us to predict a house price. So you can see the price, the area, bedrooms, bathrooms, stories, and so on. And then the model is the algorithm that we selected plus the rules, the patterns that it learned from the data. So that is the model. There's some Python code. We can't really talk about AI or software engineering without showing you some code. You can see it's reading this spreadsheet as the data set. And then it's teasing out those attributes that we talked about. Is it on a main road? Does it have a guest room? And so on and so forth. And then the actual machine learning is actually very simple, and we'll show that in a moment. Really simple. But once we've done this training, we want to predict the house price for a house that we haven't seen before. Sometimes we want to analyze or visualize. So here's linear regression that shows us the price versus the area relationship between all these data points. And that allows us to talk about what the price should be. We can also plot it in more advanced ways along many dimensions. But the code that does the model creation and the training and the prediction is, you're looking at that code, 3 lines of code. So it's deceptively simple, but it's extremely, extremely powerful, and also can be very problematic if it's being misused or it's being used by someone who doesn't understand the fundamentals of machine learning, computer science, and data science. So this line here is creating the model, which is, you can call it an empty box that has no rules in it. This line here where it says fit, this is simply saying find patterns in the data and put it inside this box, right? The data is this data here. This is a matrix you can think of, and these are the answers, the actual prices. And now we have a new house or multiple houses that we don't know the price of, or we want to know what the price should be, and we can ask the model to predict. And these predictions are simply a collection, a list of prices. That's it. And why do we have a complete subfield for machine learning? That's a story for another day. So hopefully that gives you some understanding of this thing we call AI. So let's take this to part 2, 7 A's of AI. Again, this is something I envisioned back in October. It's still an active research work in progress. We looked at all the AI tools and methods and techniques, and we said, there are many ways we can look at this, but let's identify what's so special about them. So that was the first thing that stood out. Autonomy. These are like self-driving cars or a robot on assembly line, operates independently without human intervention. That's probably the highest level of the AI kind of state of the arts today. Below that is adaptation, being able to deal with uncertain and changing environments and learn from it. Below that is things that we do today and we have been doing for many years, automation, like the automator tool. ask it to, perform these tasks. There are some rules, and it does it. Um, in fact, in the 80s and 90s, that was rule-based systems engineering. Augmentation is to say we can help humans enhance what they're doing by using AI tools, and I'm going to show examples of that. Agency and assistance. So here we're taking decision making to another level. We want to ask the machine to create an itinerary for travel, but we don't want the machine to ask so many questions because the machine knows our preferences. I like an aisle seat. I like to sit in the front, and so on and so forth, right? And it's able to make all these decisions with limited input. We call that agent computing. And when I was going to computer science school in the late 90s, that was quite a hot field. Assistance is something we do all the time. We ask our machine for the weather, or ask the machine to start a timer, and so on and so forth. So it's not replacing decision making, it's really just helping us with mundane and sometimes meaningful tasks. And lastly, an accessory. So AI methods and tools are becoming more of our, style, fashion, comfort, appearance, everyday living. And this is sort of it's increasing order. So one is, we think, is the highest intelligence for the machine to be able to independently work by itself. And then at the bottom, it's important, but it's still very manageable. So here are some examples. So here you're looking at, a robot. It's roaming the factory floor, and it's able to fulfill an order. So it's completely independent without human intervention unless something goes wrong. Adaptation, we do that all the time. We use these streaming services. So these recommendations you get from Netflix, that's a type of adaptation, because looking at your preferences and what you have done in the past, and maybe the time of today, other aspects, other users. So this is the global list for English-speaking audience. Taking it back to automation. So automation is different than autonomy, right? Here, the robot is doing all these tasks independent. It's not prescribed. Automation is to say there are 10 tasks that needs to be done, and this robot is performing them. It's placing this particular product in the box, it's going to seal it, it's going to move it, and so on and so forth, right? And of course, it doesn't have to be a robot. It could be a software bot, or it could be a combination. Augmentation, I think we've been doing that for quite a long time. But the example that comes to mind is graphics design tools that allows you to automatically align, adjust colors, adjust layouts, and make suggestions to fit the design that you're working on. This used to be very, very tedious work. Agency is, well, it's a cute robot. The robot is making the itinerary for us. So it's going to book the airfare, it's going to book the hotel, it's going to book the attractions, it's going to take into account my preferences, my wife's preferences, and so on, and maybe the guests. Let's say we're having a birthday party, it's going to take into account what are my preferences for that and the family, and who are the guests, and where is it going to take place? Is it going to be at my house, someone else's house, or a public place? All of that is going to take into account, and it's able to do that. Just like a human agent. Human agents are hip, they're resourceful, they're able to do things, they're able to negotiate, they're able to manage, right? They don't keep asking questions. Assistance is something we take for granted now, right? So we ask these devices to give us information. So it's about information retrieval or performing simple tasks, right? And then accessory is where it gets really interesting, where the device or the AI method is embedded within your daily living. So this could be a fitness device, it could be a smart shoe or apparel. There are these things. Recently, there are actually the first smart running shoes. I don't have one, but that's quite interesting, right? So it's given us, it's helping us be better in our everyday living to a degree. Obviously, all of these have their own degrees and their own shortcomings and gaps. So those are the 7 A's, right? And as I said, it's really like a hierarchy. At the very top is autonomy, and at the very bottom is accessory. This is work being umbc. This is, and we're going to take that further. So what's next? I think that's probably the most important part. And we'll try and get through this quickly here. You know, any new technology is always faced with doubts, and oftentimes a new technology has issues and problems. And in fact, oftentimes the new technology is, we call it garbage or rubbish. But we know that the new technology will become better and the issues with it will be resolved as long as enough users participate in the solution, in its evolution. So the message that I give to myself and others is to embrace, adapt, and extend. Many of the big tech companies in the space, they survived, including Microsoft and Apple, because they have this mindset, embrace and extend. Even if it came from Apple, Microsoft said embrace and extend it. Apple, similarly, even if it came from Redmond, Washington State, embrace and extend it. So, you know, AI methods are being employed here when we get on a flight, right? Autopilot's been around since the 70s, right? Pilots are not taking care of every little detail. If they did, they would probably lose 5 pounds of body fluid while in their cockpit, right? So we need to embrace it, but also have a healthy dose of questioning and rigor, right? Because there are tools and methods that are not worthy. There are a lot of things that are being produced for the sake of commercialization, capitalizing on this kind of AI gold rush. And then take what works for you and adapt it to your needs today and tomorrow, but don't stop here. Extend it, innovate it into the future. So that's one. So to kind of put this concretely, reading is important, is a lost art. So these are the first two I know firsthand. They're great textbooks and books in the space. The last one is a non-technical introduction to AI. That might be useful as well. And then in addition to that, experiment. Even if you don't have a technical background, Python is a fairly user-friendly programming language and environment. But also beyond Python, there are automation tools that you can use to do something productive in your everyday life. From if this, then that, and Zapier, and I showed the automator, and I believe there's a Win automation and AutoIt. So this is just a sampling of some tools you could potentially play with. So you can see both the power and the pearls of what some of these tools may bring. This is not a plug for umbc, but these are some interesting training courses that we have. There are other training courses that are available from open coursework and other spaces. Understanding software and understanding AI is a human right. It's not something just for software engineers and computer scientists. Every person on this planet needs to understand it because they can't avoid it. They must use it, right? So what's next? The answer is humans at the center, humans and AI. In order for us to be successful, and this is me projecting the future, which is a risky thing to do, 5, 10, maybe 20 years from now, in order for AI to really serve humanity, we need diverse participation in AI methods and tools from around the world. And I know that word diverse has its own meaning these days, but I will not go there. That will lead us to we humans building responsible AI. That is AI that takes the user first and foremost. And that will take us even one further step. We'll be able to explain the decisions made by AI in many applications. That is not possible today. Almost zero applications you can explain why this decision was made. So taking it further and looking at AI as software, advanced software, we will, at some point in the future, say 15 years from now, we will reach what I call AI commons. which means all these methods and techniques that we're so excited about and we keep hyping become like second nature, like running water. We may even reach the ability for you and I to have our own private LLM or even our own private search index. That will be a huge change, a sea change. And that will drive AI to become trusted and safe for everyone, every person on this planet. So in conclusion, AI, if I were to give you one word or two words, advanced AI equals advanced software. And to do AI, you need data sets, authoritative data sets. And then you need to create a model that has an algorithm and the rules. And then you need a lot of advanced computational techniques from software and hardware. There are many promises and many challenges. But in order for us to be successful, we must use AI methods responsibly, because at the end of the day, we should start with this. We need to engineer software systems that are ethical, reliable, and beautiful. And that's all I have for you there. There's my email address. I'm happy to answer any questions. If you have questions after the session is over and the QA session is done, and also there's a URL for our lab, the Ethical Software Lab, esl.umbc.edu. So with that, there's a survey for you to participate in, so we would encourage you to do that. And then we are going to go to questions and answers, and I know we're at 12:30, so let's see here. Are there any questions? And I'm looking at the chat here. I'll go ahead and stop sharing. Rex, I'm going to hand it over to you to see if there are any questions. Okay. Candice asks a question, do you have any recommended resources for AI in healthcare? That's a great question. The one that comes to mind is IBM Watson and the work they have been doing in healthcare. Really, the biggest challenge for healthcare is to have a private authoritative LLM model for a particular medicine discipline or general medicine. So that would be the first thing I would look at. I believe Watson was a pioneer in that space. I hope that answers your question. Wonderful. Any other questions? And I'll go ahead and put my email address in the chat here for you. So if you think of questions after or later today or tomorrow, just reach out. Be happy to. How can you tell? Another question from Susan. How can you tell when AI is making things up and when you are being targeted by AI? Yeah, interesting question. It is not easy to tell when AI is making things up. So we would have to kind of do backtracking, reverse engineering. In some ways, you would have to know the answer, or at least some sense of what the answer should be. So early on, I think when ChatGPT came on the scene, I asked a question about, give me a training plan for half a marathon. And I knew what the answer is because I'm a runner. And it suggested that I ran 11 miles the day before, which is completely garbage, right? You have to taper and you can't be running several days before your race if you're going to, set any new records or, not being injured. So there are some tools, but they're still in the early days. So one way to deal with that is to ask the question of multiple tools. So let's say GPT, DeepSeek, and maybe you can ask the same question of 3 different tools and see what answers you get. That might, if you're not clear about what the answer should be. So that would be the advice I would give. How do you know when you are being targeted by AI? Sorry to say that. We're always being targeted by AI methods, right? Much of the web lives on this idea of monetization, right? We as users, our data is being monetized. So you have to ask the question, who owns the data? How can I ensure my data privacy is protected? Know what's being shared in your profile, set the appropriate levels of control that is right for you. But today, I don't think there's a way to avoid being targeted by AI or software methods on the web. So always assume that you are being targeted. I hope that answers the question. Excellent. Okay, any other questions? We'll take 2 more questions and then we'll wrap up here. Thank you all for being patient with us. All right. Don't see. There's a link to the survey. Thank you for posting that.
Hey everyone, as Mohammad said, I'm Rex Jarrett, Director of Professional Programs here at UMBC, and I just wanted to say thank you to Mohammad for taking his time to be here today, and all of you for being here as well. So the exit survey is there in the comments. It helps us know how long these things need to be, what kind of subjects you guys want to cover, and make sure that we're offering sessions that are most impactful for everyone here. So if anyone can take some time to do that, we greatly appreciate it. And as was shared, we will have these sessions every Wednesday from 12 to 12:30 p.m. So, with that being said, thank you again, Mohammed, and everyone have a great afternoon.
Thank you all. Bye-bye.